So the first problem that I'm going to work on is finding unknown numbers. And one of the comments that I've added to this is that this is, really similar to problem solving like we've had before with one variable, except now, right, we need to choose two variables, and we're going to have them representing two of the unknowns. So in this case, I want to find two unknown numbers, and I'm given that the sum of the two numbers is 7, and 3 times the first number equals 4 times the second number, and I want to find the two numbers. So sometimes, the first thing we need to be working on is, well, reread the problem so that you make sure that you're not kind of rushing through it and you get all of that. So I'll just pause briefly here and give you a chance to reread it again. And then I want to go into what I know, what I don't know. So I think the first thing that I want to do here is to actually assign some variables. And so I am just going to say that x is the first number and y is the second number. And these are what we don't know, right? And then I have some statements here that I can put together and make equations using my variables now. So the sum of two numbers is 7. Sum is an addition, so the addition of two numbers is 7 equals 7. So from that first one, I have that x plus y equals 7. Second one, 3 times the first number equals 4 times the second number. So 3 times the first number equals 4 times the second number. So now I have two equations, two unknowns, two equations. I can solve this. I actually could do this one graphically, right? I mean, it would work. But I actually think that this one is probably set up best for a substitution. So I am going to solve the second equation here, 3x is equal to 4y, for the x variable, and then I'm going to substitute it into the other equation. So then I'm going to have to divide both sides by 3. So when I do that, I get x is equal to 4/3 y. Now I'm going to take that expression and I'm going to substitute it in for x in my first equation. So I now have 4/3 y. Write out the rest of the problem now, the rest of the equation, plus y is equal to 7. And really, I had to come up with one with fractions, right? Just a good chance to remember, what do we do when we have a fraction in an equation like this? Do you remember? It has to do with the least common denominator. We're going to multiply all terms in the equation by the least common denominator. In this case, we only have one denominator, so that makes it pretty easy that our least common denominator is that denominator. So I'm going to multiply all terms by 3. So 3 times 4/3 y leaves me with 4y. 3 times y leaves me with 3y, and 3 times 7 is equal to 21. So now I have an equation that has no fractions. Woohoo! We like that much better, don't we? 4y plus 3y, 7y, is equal to 21. Do you see where this one's going? Divide both sides by 7. Divided by 7, divided by 7. Y is equal to 3. So now I have that at least one of the numbers, y is equal to 3. So now I take this, right, and I substitute it back into one of my initial equations. Well, I'm going to go into the first one here because that just makes more sense, at least to me. Maybe you think it's not as big a deal, but to me it looks like that. It'll just be easier. And I have x plus y, but I'm going to replace y with the value of 3 that I already found is equal to 7. So I need to subtract 3 from both sides, and I get x is equal to 4. So now I have both numbers. Does that work? Does that fit both equations? That's my last step, right? I need to check. Definitely 4 plus 3 is equal to 7, so yes, it works in the first equation. And 3 times 4 is equal to 4 times 3, so yes, it works in the second equation. So the two numbers are 3 and 4. And that equation, that application is solved. Let's move on to another one. Solving a problem about prices. Alicia purchased tickets to a local comedy club for 5 adults and 2 children. The total cost was $161. The cost of a child's ticket was $7 less than the cost of an adult's ticket. Find the price of an adult's ticket and a child's ticket. Okay, what's the first step? Reread the problem. So I'm going to give you a little bit here to reread the problem. Okay, so now I'm going to think about, first thing I have to think about is, right, I'm going to have 2 variables here. And this is one of those cases where it actually, I think, is easier to assign some letters that make more sense. And so I'm going to call A is the price of an adult ticket. And I'm going to call C the price of a child's ticket. Okay. So what else do I know? Those are kind of the unknowns I'm going after. I know that 5 adult tickets were purchased. I also know that 2 child tickets were purchased. And I know that the total cost for all 7 of those tickets was $161. Do I have more information in here? I do. The cost of a child's ticket was $7 less than the cost of an adult's ticket. And I think that if we think about this carefully enough, we could actually put this one into an equation right away. I'm going to need to make an equation with this first group of information, but this one I think we can put into an equation right away. So the cost of a child's ticket was, so C equals $7 less than the cost of an adult's ticket. Remember, we've got that less than connotation. What happens when we have words with less than that are telling us it's a subtraction, and we write an equation, right? We have to swap their places. So C is equal to A minus 7. So I now have one of my equations. And it looks like I have one of my equations solved for one of my variables. So this is looking to me like it's going to be a substitution problem. So now I need to put together some information for the other equation. Okay, so let's think about this. So the total cost. So how are we going to get the total cost? Well, to get the cost of all that was spent on the adults, there were 5, and we have to multiply that by the price of each ticket. And to get the cost of the children's tickets, there were 2 of those purchased, and we have to multiply those by the price of a child's ticket. That's our variable C, right? And then we know that the total cost, so the sum of the cost of the adults' tickets plus the sum, so the cost of the adults' tickets, right, were 5A. And we said that the cost of the children's tickets was 2C. And we know that the total cost, so the sum of those two, is equal to 161. So, 2 equations, 2 unknowns. I'm going to substitute again. So, I'm going to take this, which is an expression equivalent to C, and I'm going to put it in here. So now I have 5A plus 2 times the quantity. Remember, we have to put the quantity in here. A minus 7 is equal to 161. So then we have 5A plus 2A minus 14 is equal to 161. Add the combine, right? I'm going to add the like terms that are on the same side of the equation. 5 plus 2 is 7A minus 14 is equal to 161. Now I need to add 14 to both sides, and I have 7A is equal to 175. Divide both sides by 7. A is equal to, 7 goes into 17 twice with a remainder of 3, so that 3 goes with a 5, so it's 35. 7 goes into 35 5 times. And, you know, that makes sense. I tend to like to think, especially when I have things that are in 25, I think about quarters. 7 quarters would make $1.75, so I feel pretty comfortable with it, that math. So now I have A. I can go back and substitute it into my first equation there. So C is equal to A, and I'm going to use the value of 25 for A, minus 7. So C is equal to 18. So an adult ticket was $25, and a child's ticket was $18. What's the last thing I still need to do here? I mean, I wrote up my answer, but what do I need to do? I need to check, right? And so if I take 25 minus 7, that's definitely equal to 18. So I'm good there. And then I have to also apply, does 5 times 25, so here's my check. 5 times 25 plus 2 times 18, is that equal to 161? Well, again, quarters, right? So 5 times 25 is 125. 2 times 18 is 36. So I'm going to add those together. So 6 and 5 is 11. Carry the 1. 3 plus 2 plus the carried 1 is 6 and 1. So woohoo, it checked. So that is the correct answer to this problem.